And yeah, thank you very much.
Just stay up, Sam. So I'd like to ask Neeraj and Bill to come back up, and the audience is free to pepper them with your questions about the program. Jason, if you want to join us up front, I don't want to put you on the spot, but feel free to join in case there's programmatic questions that.
If a question comes that way, I will.
Okay, thanks. All right, so questions for
Here.
lots.
Do you have space architects in your companies working for this?
I'm sorry, what was the question?
Do you have space architects in your companies?
Yes.
How many? Where? What do they do?
Probably more than we need.
Okay.
Everyone's a space architect.
I think what Jack is
Profession.
asking is, do you have people who have advanced degrees in architecture?
Correct.
Ah.
So I can answer.
Yeah.
So we're located in Houston, actually quite close to the Space Architecture School at University of Houston. And we've worked with some of their students before, and we have actually one of their students in-house working with us now, a space architecture student, who I believe their background before a space architect was actually terrestrial architecture.
Okay. How about?
Yeah, so we've done something similar. We've contracted with different companies to look at it that have space architects. We also have some folks in-house that have that type of a background as well.
And for us, I would say most of our architects are systems engineers by trade, and then they go through special training that the company provides to become system architects. So that's generally how we do our architecture.
Thanks.
Yeah, go ahead.
So you mentioned your station isn't manned all year around, so how do you deal with partial failure, like for example recently the leak on the ISS Dury and there are no astronauts on your space station?
Right, so that's a really good question, and I think for us it comes down to high levels of automation and robotics that sort of like what I was talking about earlier, where the ground crews can jump in and they can actually interact with the spacecraft and troubleshoot from the ground.
Yeah, we could similarly, robotics and on-orbit autonomous operations, I think are key to having that capability. Also looking at different ways to mitigate things that may happen on orbit, like you said, if there was say a puncture in our inflatable, we've looked at ways to change the pressure of the system or ways to mitigate what that leak would be.
Agreed.
Just one thing, okay?
So similar to the first question, do you have anybody on board who is doing human-centered design? All of the few presentations are perfectly good technological solutions. I haven't seen anything discussing how to address astronaut needs, besides some of the activities. Now those are basic need activities.
You're
but
talking
higher
about
level needs.
human factors.
Even beyond that, human factors high level needs,
Human
instead of just
systems
they can
integration.
survive here for a while.
Right, yeah, so for us, I just didn't show it, but we do have a fair amount of that human factors kind of work, and then also feeding into the testing that we will be, I didn't really talk about that a whole lot, but when our prototype is complete, we'll be doing a lot of day in the life kind of testing where we'll actually run through use cases and scenarios and off nominal conditions, things like that, to make sure that we've got the right layout. And it's hard to do in 1G, but yeah.
So we're doing something very similar. We do have layouts. I didn't show them as well, but we do have full interior layouts in different orientations for what the each one of the habitation areas would look like. And you might have seen on one of my charts I showed there's a 2-level split of the interior of the life habitat there. So we are building that and we're going to evaluate exactly, and that's actually what we expect to do in flight as well. And we're going to evaluate through our testing as well on that full-scale prototype how crew interacts with it, how they can move around, how they can move experiments from one location to another, how the crew quarters are, and so forth.
Yeah. Yeah, a lot of our design actually is influenced by our experience working with astronauts on orbit and our operations team at NanoRacks now. But over the next year, we're going to be refining that based on some partners working specifically on human factors. So I would encourage you to check the website and next year come for some more detail on that.
Okay, yeah, go ahead.
So my question is about attitude control, especially this year in Nevada design. You had kind of your secondary PPE that was not really lined up with the center of mass. I was just curious, are you going to rearrange that if you need to use the backup system? And then maybe for Lockheed and for Sierra Nevada, how do you deal with flexible body dynamics when you're performing propulsive maneuvers?
Yeah, so we do have the flexibility of locating that PPE, either the first or the second in different locations to allow for that control. But we've also looked at it as what is the control scheme with each one of those PPEs in different locations. And we found that we can completely control the entire system as you saw it up there. There's different techniques we're using to doing that.
Yeah, and actually, this is an even more important question than you might realize, because the PPE is the first element of the gateway. And so it has to be sized to be able to control a stack that hasn't really been defined yet, right, that will grow over time. So we do a lot of work on different configurations of the gateway, some with higher inertia, some with lower inertias, different CGs and offsets, to make sure that we've covered as wide of an envelope as possible for all the different configurations that you might get. And so that's really important. I'm not a GNC person, so in terms of the flexible body dynamics, I probably don't have a great answer for you on that. But the other thing I would say is that when you're doing the attitude control, you have to also look at translational maneuvers and how that impacts it too. And so you get some unwanted delta V's sometimes when you're trying to make those maneuvers. And when you're in an orbit like this, you have to be careful that you don't actually put yourself on an undesired body trajectory or something like that. So all of that has to be taken into account when you're doing the attitude control.
Thank you.
Go ahead.
Because there is no magnetic field near the moon.
What?
No one told me that.
How do you try to protect the astronauts against solar eruptions?
Yes, so that's also a really good question. First of all, in our architecture, we rely on Orion a lot for radiation protection. Orion actually is designed through the Alera principles, which is basically according to a solar particle event of a certain magnitude. And so in the case of a solar event, the crew can actually go into Orion and be protected from a solar storm. So as a minimal capability, we feel like the gateway is covered for the kinds of mission durations that we're talking about. But also, the gateway is a really important infrastructure to start really testing mitigations for those longer duration missions. So having material science lab there that can test the different material properties for different mitigations is really important.
Yeah, I'll say, in our architecture, we've also looked at Orion as being a safe haven, but we've also looked at the inflatable. So one thing that's interesting about inflatables is they're actually really good for radiation protection in certain situations. So we worked with the team at NASA to actually evaluate what the radiation tolerance is of that system, and can use potentially the inner core of our life as a secondary radiation shelter.
Okay. Good. Okay, go ahead.
Sam, I think.
Yeah.
I saw in your table of potential alternative rockets that you were considering the Proton M, which has a hydrogen tank.
Yeah,
Is
that's a
it
great question.
really-
Could you repeat it for everybody?
The
sorry.
question,
Louder, a little
the
bit.
question was reusing the Proton M, which does not use LOX hydrogen as its primary propellant. And right now, the launch vehicles that we're focusing on are LOX hydrogen vehicles, but we're also investigating for feasibility. We've identified that LOX hydrogen is feasible, but beyond that, we're investigating options on how we might be able to clear those tanks out as well. Oh yeah, great question.
Okay,
Other questions?
go ahead.
How do you handle the delay in communications during eclipse and generally in teleoperation with the robotic arm?
Yes. So, to me, okay. So the answer to that is we do it a couple different ways. So we face antennas so that we can get constant communication. So at least from a location, from the rotation of the vehicle itself, we have complete communication. Now, in times of eclipse, we expect there are times that there will be outages and that the system has to work on its own. Now, those outages may not occur from the moon to gateway system, they may be from the gateway to the Earth system. And so there's different operations in each one of those that would occur. So for instance, you would always be able to, you should be able to always communicate with the lunar surface. So if there's surface operations, you can always have a communication between the two. But we do expect there to be some outages, as is normal for any type of satellite in LEO, for instance. So, but it's not an unusual thing.
Yeah, I would say, just to tag onto that automation is an important part of that, but it's supervised autonomy. So if you're doing robotics on the gateway from Earth, you're not necessarily, like you saw here, you're not necessarily joysticking the robotic arm real time. You're basically saying, go to this point, and the robot goes there, pick this up, it picks it up, it knows, it's fully aware of its surroundings and has a real-time model of the environment. So you don't have to have that kind of precision, and you can deal better with latency. But latency is a challenge. It's even worse for Mars.
Okay.
I have a question, I guess, which I think is gonna be the last one in the interest of time, but, I think it's great to see a diversity of approaches, and so I thank you all. I have a hard question for you, Sam.
Great.
Which is, compared to what I would, call a more conventional approach, is the NanoRacks approach has a bunch of stuff in it that's never been done.
Yes.
And so, is it problematic that the list of qualifications that need to be done to enable that concept, you know, solar cells that can be on the outside of a launch vehicle and robot arms that can be inside and outside and so forth, is that feasible programmatically within the framework of the Gateway program?
So, yeah, our standpoint is, first of all, NASA is really helping to enable us to buy down a lot of the risk in developing these new programs. So we finished phase 1, and we haven't quite caught up to these guys in demoing and doing a lot of the ground tests that we would need to show that this can work. But that's in our future plans. And then the other thing which you're not seeing here is, this is sort of I would say the highest complexity option. But we do have an overall NanoRacks program plan to build this up over time while the ISS is still in LEO, and we have all the infrastructure there to help us buy down that risk.
That's a good approach.
Basically very slowly and progressively. So we're not gonna go launch this, as our first station, certainly not.
Okay. Well, great. With that, I'd like to